Tonight's voyage takes us to the brink of the explored realm. We find ourselves on a serene coastline, gazing toward an infinite expanse of azure, attuned to the rhythmic sigh of the surf as it approaches in languid, recurring swells. From our perspective, the ocean appears as a domain of regularity. The tides advance and retreat with clockwork precision. The breakers advance upon the shore in predictable sequences, a mesmerizing cadence that has pounded the landmasses for eons. This cadence soothes us. We rely on it. We construct our vessels, our drilling platforms, and our seaside settlements predicated on the belief that the sea adheres to principles. We draw reassurance from the norm. Should the waves reach 3 meters, we reassure ourselves that a 5-meter swell is possible. Yet a 30-meter monster is unthinkable. Yet this illusion of structure is misleading. It's a reassuring narrative we craft to feel secure on a world dominated by water. In reality, the ocean harbors no recollection and owes no allegiance to the norm. It functions as a turbulent liquid dynamo brimming with colossal power. And at times, for causes that researchers are only starting to unravel, the calculations falter, the cadence falters, and the sea rears up. On this expedition, we direct our attention to the profound, capricious core of the waters. We pursue the beasts lurking in the depths, not sharks, whales, or octopuses, but the element itself. We're following the trails of freak waves. For ages, they existed solely in legends. Hushed terrors recounted by mariners who swore they'd witnessed towering barriers of foam surging from tranquil seas. Sheer ramparts of fluid that engulfed vessels whole and erased all evidence. Experts once scorned these accounts as distortions born of exhaustion, terror, and spirits. But today, we confront the disturbing reality. They exist. They're surging across the seas at this very moment, and they're vastly bigger and far more prevalent than we'd ever care to admit. Along this path, we'll delve into the peculiar mechanics that enable a swell to siphon strength from surrounding waves and swell into a colossus. We'll enter the last instance of ships that disappeared sans any mayday, and we'll softly ponder. Amid warming seas and intensifying forces, are these titans stirring? Prior to confronting that aqueous barrier, pause to ground yourself on solid earth. If this gradual immersion into the enigma of the profound waters brings you peace, feel free to like the video and subscribe, but only if these explorations truly resonate with you. Share in the comments where you're tuning in from this evening. Are you near the ocean or deep inland? It's intriguing to discover how diverse shorelines and urban centers link through shared currents. Now, settle into a relaxed spot. Lower the lights, perhaps activate a fan to mimic that gentle, constant drone resembling breeze across the vast Atlantic. Inhale deeply. Allow the day's stresses to unwind and dissipate. The port recedes astern. The chart is set aside. We embark now into the facade of serenity. To grasp the beast, to fathom how a swell can turn lethal, we start with the basics. The undulation. We examine the sea's respiration. A wave isn't water in motion. That's the initial profound misconception. As you observe a wave propagating over the surface, the water doesn't actually journey forward. Instead, it merely ascends and descends in orbital patterns. It's the energy that propagates. A wave represents an ethereal surge of power traversing the ocean's medium, and that power originates from above. It commences with contact, the drag of air brushing the water's face. A mild gust generates minute, disordered undulations, capillary waves. These undulations texture the surface, affording the wind greater purchase, more surface to propel. Should the wind persist, the undulations expand. They coalesce, they align into a cadence, they evolve into gravity waves. Three factors govern a wave's magnitude: the wind's velocity, its persistence, how long it endures, and the most lyrical factor, the fetch. Fetch denotes the expanse. It's the unobstructed span of water, across which the wind can sweep unchecked by shore. The Pacific boasts a fetch spanning thousands of miles. It serves as an immense open corridor where gales can infuse the depths with vigor for weeks on end. That's why the swells of the Southern Ocean, encircling Antarctica without continental interference, rank as the planet's grandest and steadiest. They emerge from boundless fetch. In typical conditions, these waves achieve equilibrium. Gravity seeks to flatten the water. The wind endeavors to elevate it. They compromise on a form, a Gaussian distribution. The majority hover at median stature. A few dip lower, others rise slightly. It's an egalitarian flow. This is termed a linear sea state by marine scientists. It's a realm governed by basic arithmetic. When a 2-meter wave encounters another of equal height, they may combine into a 4-meter crest. It's foreseeable. It's secure. It's the framework that shaped every 20th century vessel. Yet the ocean doesn't invariably behave linearly. Occasionally, in the profound gloom distant from any coastline, the sea abandons the principles of mere summation and embraces those of multiplication. At times, the interplay of winds, currents, and the ocean's contours aligns to produce a nonlinear occurrence. An instant when energy doesn't scatter, but gathers intensely. An instant when the spectral presence beneath the surface transforms into a fiend. To grasp this phenomenon, we need to examine the error we committed. We have to confront the deception inherent in averages. In our efforts to subdue this disorder, people devised a measurement. We required a method to characterize the sea state, a figure suitable for plotting on charts or relaying via radio to alert far-off vessels. Thus, we developed the notion of significant wave height. This serves as the benchmark. It's the terminology mariners employ. When a skipper gets a report indicating 3 meters seas, it doesn't imply that each wave precisely reaches 3 meters. The sea isn't some factory churning out uniform replicas. Instead, it's a varied pattern. Certain waves form mere undulations, while others build into substantial surges. Significant wave height involves a particular formula: the mean elevation of the top 1/3 of waves within a defined time frame. It was crafted to align with the observations of a seasoned sailor viewing from the wheelhouse. This approach disregards minor perturbations and emphasizes the substantial breakers that count. For ages, this framework proved effective. It instilled a feeling of mastery. It enabled ship designers to construct vessels capable of enduring anticipated peaks. We engineered our drilling rigs, warships, and freighters, relying on a probabilistic framework known as the Gaussian distribution or bell curve. The bell curve embodies the reassuring order of the natural realm. It suggests that outliers are exceedingly uncommon. If the typical stature of an adult male stands at 1.7 meters, you could encounter someone reaching 2 meters. Perhaps over a lifetime, you'd spot one at 2.5 meters. Yet the bell curve assures that strolling through town, you'll never cross paths with a 10-meter giant. It's probabilistically unfeasible. We extended this reasoning to the sea. We assumed that with a significant wave height of 5 meters, an 8-meter breaker might appear. In a once-in-a-century tempest, perhaps a 10-meter one, but a 25-meter behemoth, a 30-meter aqueous barrier. The figures declared it impossible. Such a swell would arise only once every 10,000 years. It was a mythical rarity, a mere tall tale. However, this dependence on means constitutes the illusion of the superficial. It's a betrayal by numbers. We erred in presuming the ocean adheres to the courteous patterns of other natural elements. But the ocean defies the bell curve. Amid the turbulent fusion of gales and waves, the distribution doesn't fade smoothly. It features a fat tail. There are episodes when the sea ceases its equitable wave governance and turns despotic. Episodes where force doesn't spread evenly, but amplifies. Episodes where norms lose all relevance. A vessel might navigate waters predicted at a tolerable 4 meters. The commander feels at ease. The team rests. The equations support them. Then, from the obscurity, beyond the cadence of standard swells, emerges an anomaly that shatters the projections. A solitary incident that disrupts the pattern. This reveals the shortcomings of our predictions. We sought to corral the untamed depths using straight-line calculations, yet the depths are curved and unpredictable. And when equations falter, the beast emerges. So, what precisely lurks in the shadows? What are we pursuing in the void? To dread it properly, we first must delineate it. We have to dispel the misconceptions, as the term rogue wave gets misused frequently. It's not a tsunami. A tsunami stems from tectonic shifts. It originates from terrestrial forces, not atmospheric ones, triggered by seismic activity, avalanches or eruptions that shift enormous water masses. In open waters, a tsunami remains subtle, a prolonged, swift, shallow rise, spanning hundreds of kilometers, yet merely a meter elevated. A craft could traverse it in profound seas without detection. Only upon encountering the drag of near-shore shallows does a tsunami swell into terror. It's a scourge for shores, not the expanse. Nor is a rogue wave a storm surge. That involves sea levels climbing due to a cyclone's low pressure, drawing the surface aloft like a vacuum. It's a gradual inundation. A rogue wave stands apart. It's an inhabitant of the vast blue. A wind-generated surface gravity wave evolved into an aberration. Science offers a stark, exact portrayal. A rogue wave exceeds twice the significant wave height. Surrounded by 5-meter waves, it hits 10 meters. In a fierce gale with 12-meter seas, it doubles to 24 meters. Yet, statistics fail to convey the dread. The criteria overlook the form of the abomination. A typical gale wave follows a predictable tempo. A typical storm wave follows a predictable pattern. It features a gentle, extended rear slope and a frothy, disintegrating face ahead. Think of it as a watery mound. Vessels climb its rear and descend its face smoothly. The movement involves swaying and tilting. In contrast, a rogue wave isn't a mound at all. It's a sheer barrier. Those who lived through it recall a deep trough in the sea, chased by a towering cascade of foaming surf. The incline defies belief, nearly straight up and down. Frequently, it surges from an unexpected angle, unlike the dominant winds and swells, striking a vessel sideways, its weakest position. There's no gentle rear to it. Instead, it's an isolated spire of fluid that erupts abruptly amid turbulent waters, looms for a handful of heart-stopping moments, then topples with the force of a toppling skyscraper, before dissolving into the ordinary swells. What heightens the dread is its isolation. It strikes as a lone outlier amid lesser waves. Consider the mental toll. You're enduring a tempest. You've adapted to the gale's cadence. Your footing on the deck feels sure. You've come to rely on the routine. Then, glancing upward, you spot a swell eclipsing the night sky, one gazing down at your command center. It defies logic. The principles of physics you've studied insist it can't exist. Yet there it looms. For ages, this notion, a perpendicular curtain of water emerging in calmer conditions, was dismissed as barroom folklore. It served as the alibi for inept commanders whose vessels vanished. A colossal swell claimed it, they'd claim. Meanwhile, experts in cozy studies in London or New York would chuckle and dismiss it. They trusted their data. They clung to probability distributions. Yet the sea has a knack for schooling those who depend solely on documents. Those tales weren't fabrications. The notations in captains' journals were cautions. It's time to set aside the abstractions and journey into the past. We need to heed those notations. We should venture to the period preceding radar and beams, onto the creaking timbers of 1800 ships, where accounts of these beasts came solely from trembling survivors scribbling by lantern glow. For centuries prior to orbital imagery mapping sea surfaces or beams gauging wave peaks exactly, awareness of rogue waves survived in just one domain. It endured in the recollections of those who escaped. It persisted in the murmurs. Picture the atmosphere in a humid, hazy pub in Liverpool, Hamburg, or Nantucket during the mid-1800s. A mariner, aged beyond his years, his hide toughened like hide by brine and sunlight, hunches at a bench. He recounts a tale, verging on insanity. He describes an evening of constant, fierce gusts, a choppy yet navigable expanse, followed by a hush, an abrupt break in the vessel's sway. He recounts peering into the void and witnessing an obstruction spanning the skyline. Not clouds of tempest, but a shimmering vertical barrier of foam, extending east to west. A barrier that advanced rather than curled. He depicts the craft, plunging into an abyss so profound the spars appeared to graze the heavens, then staring skyward at a shattering peak suspended 100 feet over the planks. Such narratives abounded. They aligned remarkably. Spanning the Indian Ocean to the North Atlantic, the accounts echoed one another uncannily. They mentioned the three sisters, three enormous surges arriving one after another. They evoked the pale barrier. They described hulls splintering from one strike. Yet upon docking, when these seafarers attempted to document these clashes with officials, maritime firms, and scholars, they encountered another barrier entirely: skepticism. The scholarly circles of the Victorian age sought to classify and subdue nature. They prized structure. They revered probability curves. To marine experts ensconced in snug, arid reading rooms in London, a 100-foot swell was mechanically unfeasible. It contravened the era's equations. They scorned the seafarers, branded them inebriates, accused them of falsehoods. They blamed sightings on mirages from storm fatigue or tall tales masking their steering blunders. No swell, the experts proclaimed assuredly, could exceed 50 feet without crumbling from its mass. This marked the hubris of theory versus the raw input of observation. The sorrow lies in the seafarers' honesty. They had confronted a turbulent truth that knowledge wasn't prepared to embrace. They had witnessed the unpredictable sea, but since their proof was personal, jotted in unsteady script on damp journals instead of instrument logs, it vanished. The sea guarded its mystery. The aberrant swell stayed legend, a yarn to unnerve young hands. But the sea pays no mind to mortal convictions. The sea pays no heed to equations or expert agreements. Yet during the opening decades of the 1800s, a renowned French naval officer and adventurer, risked his professional standing on one bold account. He became the initial scholar to declare openly, "I witnessed it." His candor earned him mockery from every corner of the globe. Superstitions were simple to brush off when voiced by nameless sailors. However, in 1826, the vast waters confronted a figure impossible to discount lightly. Gilles Dumour. D'Urville wasn't some fanciful yarn spinner. Instead, he served as a researcher, a botanist, and a notable figure in the French Navy. Schooled in meticulous scrutiny, his livelihood rested on exactitude. At the helm of the corvette Astrolabe, he led an expedition, mapping uncharted southern seas. A product of the Age of Reason, he clung to verifiable truths. Still, the southern Indian Ocean possesses a knack for twisting realities. Conditions turned stormy. The Astrolabe pressed through perilous passages below Africa, an area recognized today as a key origin point for colossal waves. Swells battered relentlessly, whipped up by persistent westerly winds. Yet D'Urville's sighting that day shattered all limits. From the deck, he observed a massive surge building astern. Far beyond an ordinary undulation, this loomed like an advancing peak. It overshadowed the Astrolabe entirely. Plunging into the succeeding valley, D'Urville stayed composed. He gauged it carefully, glancing at crew members aloft in the sails, then up at the wave's summit rising far beyond. He ran the angles mentally, drawing from his ship's familiar proportions. He computed the surge's stature. The result chilled with its accuracy, reaching 80 to 100 feet, about 30 meters. This defied every law of nature. Had it crashed then, it could have smashed the timbered corvette to splinters. Miraculously, the Astrolabe endured, climbing the behemoth's slope like a plaything, quaking across the summit before crashing into the far descent. Back in Paris, D'Urville faced the learned assembly. He shared his journals, he laid out his figures. To the Academy of Sciences, Europe's foremost authority on discovery, he reported encountering a 100-foot breaker. Laughter met his words. The scorn came chiefly from François Arago, an exceptional physicist and astronomer. From his cozy Paris seat, backed by era-leading wave mechanics, Arago dismissed the Voyager as mistaken. Equations, he argued, capped sea swells at 30 feet maximum. Greater claims smacked of impossibility, optical illusions or tall tales from the crew. D'Urville endured open disgrace. Doubt in his reliability tarnished a flawless record. He passed away much later, unaware of his vindication. Unaware he'd confronted a rogue wave head-on, outlasted it, yet fallen victim to the smugness of land-bound skeptics. Over the following 100 years, this cycle repeated. The deep would reveal its ferocity. A vessel would vanish or an eyewitness would recount, only for society to avert its gaze. Refusal to accept ran total. Yet, the sea persisted. It geared up to deliver a signal, tougher to overlook, one not confined to a lone commander's view, but potent enough to obliterate a pinnacle of progress, acclaim, and supposed indestructibility from the Edwardian era. Let us shift to 1909, along South Africa's shores, and unravel the enigma of the SS Waratah. Unlike the modest timber scout Astrolabe, the Waratah stood as an ironclad bastion. Pride of the Blue Anchor Fleet, this opulent liner steamed back from Australia toward London. Stretching 500 feet, she boasted sealed bulkheads, illumination by electricity, and the pinnacle of shipbuilding safeguards. Contemporaries in authority deemed her invincible. Depart in Durban Harbor on July 26th, bound southward for Cape Town, she bore 211 aboard. Storms raged, yet for such a behemoth, they seemed ordinary. Then abruptly, she vanished. No SOS echoed, no debris surfaced. Life raft stayed lost. No remains ever reached the beaches. Amid empire's crowded trade routes, this 10,000-ton metal metropolis evaporated like seized by some colossal grip from above. For generations, the Waratah's fate ranked as history's top sea riddle. Yet amid statements from nearby skippers that fateful evening lurked a hint. The Clan McIntyre's master, a freighter that had radioed the Waratah mere hours prior, detailed an odd occurrence. He called the gale intense yet controllable. He went on to recount an eerie hush. He mentioned an abrupt, bizarre shift in the pattern of the waves. Glancing back from his vessel, he spotted a surge that resembled nothing less than a sheer cliff face. A towering, unyielding barrier of seawater, blotting out the heavens and surging across the horizon, right where the Warar had last appeared. Today we understand that the Warar fell prey to a particularly horrifying type of rogue wave incident. It probably got ensnared in the Agulhas trap, that notorious band of sea where the fast-moving, warm Agulhas current slams straight into the icy blasts from Antarctic storms. This clash, as we've since learned, generates waves of extraordinary pitch and power. The Warar didn't go down gradually. There was no chance to deploy lifeboats. The dynamics indicate she was pooped, overtaken from astern by a swell so immense and vertical that it hoisted her rear skyward while slamming her prow into the abyss before it. Alternatively, she might have been struck sideways, capsizing in one thunderous, wrenching groan of twisted metal, sealing her crew within as she plunged to the ocean floor. The sea had seized a bastion. It demonstrated that no amount of steel could defy the forces of shape and angle. Yet even this disaster was brushed off by plenty as a vessel flaw, an issue of poor balance, an overloaded structure. The resistance persisted. The sea was still viewed as a straightforward, foreseeable realm, where only large vessels sunk due to human error. Another 2 decades would pass, along with a new sort of witness, before anyone could quantify the beast precisely. It demanded a vessel that stayed afloat and an individual who kept his cool, turning instead to his calculations. Now we journey to the Pacific in 1933. Aboard the USS Ramapo, the skepticism of the Victorian era was on the verge of clashing with the rigorous equations of the modern age. Tales from inebriates and rattled voyagers were one matter. The precise measured computations of a military navigator were quite another. On February 7, 1933, the USS Ramapo, a naval fuel tanker, found itself amid a swirling tempest in the North Pacific. This wasn't some brief gust. It was a sprawling atmospheric event that had been howling for days, whipping the waters into a maelstrom of whitecaps and rage. The wind's reach stretched endlessly. Gale-force gusts of 60 knots had persisted for a full week, herding the ocean before them and layering force on force. The Ramapo wasn't battling the swells. She was riding along with them. She glided down the fronts of the undulations, her screws spinning wildly at each peak, her fore dipping deep into the valleys. Up on the bridge, Lieutenant Frederick Margrath kept vigil. He wasn't one for hyperbole. His role centered on charting courses and recording sights. As he gazed aft, squinting past the pelting mist into the silvery gloom, A silhouette loomed up astern. It was a breaker that eclipsed the stars. With the Ramapo's aftersection dipping to the trough's nadir, the pursuing wall peaked. Margraft held steady. He avoided alarm. He captured the scene mentally. He observed that, as the ship's tail reached the valley's lowest point, the waves' foaming top lined up exactly with the crow's nest atop the primary spar. He was familiar with his ship's specs. He knew the spar's elevation. He understood the deck's tilt. Back in the chart room's calm later on, he crunched the figures. He estimated the surge's stature from his vantage. The outcome seemed implausible: 112 feet 34 meters. It equated to a watery rampart rivaling an 11-story tower. It stands as the most credible measurement to date of a wind-fueled wave taken from a ship's platform. The Ramapo made it through by sheer fortune. Her length, her mass, and her buoyant response turned her into a bobber on the swell. But the observations she carried home transformed the debate. This wasn't mere anecdote. It was pure form and proportion. The deep had forged a colossus that mocked conventional forecasts. A breaker that, by probabilistic norms, ought never to have arisen in cosmic history. The inquiry evolved. Existence was no longer in doubt. The proof was irrefutable. The puzzle grew grimmer, more pressing, and tougher to unravel. How? By what process? What concealed principle of nature permits liquid to rear up like a precipice? To uncover it, we need to plunge below the waves. We have to examine the unseen flows and the peculiar turbulent equations that twist a steady sea into a snare. We're stepping into chaotic dynamics. We're heading toward the Agulhas. If any spot on Earth serves as a breeding ground for these behemoths, a precise spot engineered to forge upright seas, it's located beyond Africa's southern cape. Sailors dub this the Wild Coast. It's a swath of water where the charts themselves appear to plot against any craft. There, the shelf plunges abruptly, and the domain is ruled by a mighty warm stream inside the salt, the Agulhas Current. It races south along the shore. An enormous flood of fluid, traveling at velocities reaching 5 knots. However, the weather has different ideas. The dominant winds here, those fierce westerlies, gust from the southwest without mercy. They push the enormous swells from the southern ocean northward, straight into the path of the current. It's a direct clash between air and sea. When a swift ocean flow opposes the wave direction head-on, the water's dynamics shift immediately. The current functions like a clamp. It tightens the waves, it crushes them. The gap between successive peaks, the wavelength, gets dramatically reduced, yet the power stays intact. Unable to spread sideways, the energy surges upward. The waves rise tall. They turn shorter, steeper, and far more precarious. Typically, a wave features a gentle incline, yet, in this Agulhas trap, the wave's front curves inward. It forms a shifting hollow. A vessel heading south, carried by the current, might abruptly descend into a trough deeper and more abrupt than any engineering specs anticipate. And before the prow can rise, the following compacted massive barrier slams onto the deck. This area serves as a burial ground. It's probable that the Waratah met her fate right here. In contemporary times, gigantic tankers have seen their bows snapped like toys. Still, this hazard stems from the landscape. It's foreseeable. A cautious skipper can steer clear of the shelf's brink. The real horror of the rogue wave lies in its independence from currents. It requires no shore. It can strike amid vast emptiness on waters that appear utterly calm. To grasp this beast of the open sea, we must examine the patterns of chance alignment. The sea's surface seldom acts as a smooth, even sheet. Instead, it's a turbulent patchwork. Right now, waves arrive from the north, propelled by a far-off tempest off Iceland. Swells arrive from the west, remnants of a hurricane that faded days earlier. And nearby wind-driven chop arises from the current gusts. These varied wave sets travel at varying paces and directions. They intersect endlessly, like phantoms slipping through barriers. Usually it's a process of reduction. A northern peak encounters a western valley and they neutralize each other. The surface stays choppy but level. Yet statistics ensure that sooner or later the pieces fall into place. This is the effect called constructive interference. It's an instant of flawless spatial harmony. Picture a watery grid at a precise spot and instant. The northern swells ridge, the western swells ridge, and the local chop summit all converge precisely. They don't offset. They combine. 1 + 1 + 1 makes 3. In that fleeting moment, the force from 3 separate tempests piles up. A spire of water bursts from the disorder. It's a brief, shaky tribute to odds. It lasts maybe 10 or 15 seconds, enough to shatter a vessel before the sets overlap and the spire dissolves into the sea's jumble. That's the straightforward account. It's tidy. It makes sense. It accounts for a rogue wave's sudden emergence and swift vanishing. It covers the 3 sisters, a trio of waves that align by chance. For years, sea scientists accepted this as the full story. They saw rogue waves as mere misfortune, a throw of fate's dice, but crunching the figures showed the odds were too slim. Such alignments are uncommon. They fail to match the number of reports. They can't justify why the sea at times acts less like a mechanism and more like a hunter. Something more ominous lurks beneath. A principle implying the ocean doesn't merely pile waves. It's siphoning power. The sea plays dirty, constructive interference. The notion of waves merely amassing through ill fortune offers a neat, reassuring formula. It portrays the ocean as a straightforward setup, akin to pool balls colliding predictably. But buried in fluid dynamics equations hides a specter. There's a formula indicating the water pulls off something much more devious than a mere summation. It's termed nonlinearity. In quantum mechanics' odd realm, experts apply the Schrödinger equation to track particle motion. Curiously, that very equation rules deep sea swell patterns. It shows the ocean isn't a steady environment, it's volatile. In particular scenarios, a steady wave sequence can abruptly unravel. It starts feeding on itself. This process goes by modulational instability, or the Benjamin Fair instability. View it as a type of power hijacking. Picture a row of waves surging across the shadowy depths, each roughly equal in height and brimming with identical energy. In a straightforward linear setting, they'd maintain that balance forever. Yet in the unpredictable, non-linear realm of the sea, one wave might start behaving like a predator. It siphons strength from the one ahead, then extends its reach backward to sap the power from its rear neighbor. It devours. Nearby waves dwindle into faint undulations as the rogue one balloons into a monstrous crest. In essence, it consumes those around it. The escalation is rapid and compounding. Within just minutes, an even sea can funnel all its force into one towering spike. This accounts for the chilling accounts of that infamous void. Mariners frequently report an eerie stillness or waves abruptly vanishing right before the freak wave assaults. That's the pilfering at work. The beast has leached the ocean bare to fuel its rise. This dynamic transforms the sea into a reservoir ready to unleash its pent-up power in one intense surge. Thus, a rogue wave isn't merely a mound of liquid. It's a concentrated lance of motion energy. That's why these behemoths don't simply slosh across a ship's deck. They strike with the demolishing impact of a rigid mass. Researchers have shifted explanations from mere misfortune to flawed principles of physics. Still, even this energy hijacking demands an initial spark. It needs a turbulent backdrop to ignite the rampage, and one meteorological event delivers the ideal turmoil for such disorder. A situation where the winds themselves turn erratic. The energy pilfering, that dark, non-linear self-devouring, where the waters prey on one another, doesn't occur in isolation. It calls for a catalyst. It demands a particular brutal form of disarray. To uncover the cradle of these titans, we turn our gaze to the winds. During a typical tempest, the wind acts as an absolute ruler. It gusts steadily from one bearing for days on end, compelling the sea to conform in unison. Swells form extended, even ranks undulating like furrowed expanses of slate-hued water. For any vessel, even amid fierce gales, this remains controllable. You aim the prow against the gusts, you follow the cadence, you ascend the crest, you descend the slope. It's brutal, to be sure, but foreseeable. Yet the skies seldom follow such straightforward patterns. Atmospheric fronts pulse and whirl. Low-pressure zones spin across the Atlantic like whirling playthings. Tropical cyclones arc toward higher latitudes, fading gradually upon encountering chilly upper-air masses. And when two such colossal airborne behemoths clash, the waters fall into disorientation. This spawns what's called crossing seas. Envision a gale raging from the west for 3 days straight. It has forged a robust, forceful swell advancing to the east. Abruptly, a fresh frontal system barrels in from the north. A biting, fierce breeze lashes the surface, generating fresh waves that press southward. These two swell patterns encounter each other. They don't blend, they cross paths. From a chopper overhead at that instant, you'd witness one of nature's most extraordinary and disturbing spectacles. The water's face isn't striped with ridges. It's patterned like a lattice. It resembles a watery checkerboard. Cubic swells, fluid pinnacles surging at the junctures, profound box-like chasms yawning where the lows coincide. This is a disordered sea. And for a boat, it's the direst circumstance imaginable. The craft forfeits its groove. It can't navigate into the swells since they're assaulting from dual angles simultaneously. It plunges ahead into a dip even as it heaves sideways. The frame contorts. The metal creaks beneath the wrenching strain. The rotational torque that snaps hulls. But the true peril lies in the layout. Amid crossing seas, the modulational instability, that energy siphoning we discussed, intensifies. The lattice yields countless crossing nodes. Every junction serves as a possible nexus for the power. The sea turns into a hazard zone of summits. Precisely this sort of turbulent, interlocking configuration marked the fabled perfect storm of 1991. A waning hurricane, Grace got engulfed by a vast nor'easter near New England's shore. The gales battled one another. The waters churned into a cauldron of clashing forces. And within that turmoil, buoys detected surges that defied all logic. In such conditions, the Colossus doesn't have to journey great distances. It emerges right there, ascending from the grid's bedlam. It's an outcome of chaotic structures. We've explored the legends, we've outlined the science, we've charted the snare. Now the concepts must conclude. We shift from the theoretical calculations of swells to the brutal truth of metal under assault. We need to observe the consequences when one of these improbable, non-linear power-thieving specters collides with a contemporary vessel. The proof resides in the icy depths of the North Atlantic during the winter of 1978, where a ship deemed impervious is on the verge of disappearing. Abstract concepts and chaos theory stay theoretical until they clash with human drive. The formulas for the Schrödinger nonlinear wave equation are mere scribbles on a page until they collide with metal hulls. To grasp the genuine physical menace of these beasts, we have to examine the ruins of overconfidence. During the harsh winter of 1978, the North Atlantic hosted a pinnacle of German shipbuilding prowess. The MS München wasn't your typical freighter. As a lash carrier, lighter aboard ship, she stood as an enormous, intricate, and advanced industrial behemoth, meant to transport scores of smaller barges. Stretching 261 meters in length, she represented cutting-edge technology, and most importantly, both her designers and sailors deemed her unsinkable, constructed to endure the Atlantic's fiercest assaults. She boasted a towering bridge, robust engines, and an impenetrable hull. Departing from Bremerhaven on December 12th, she headed toward Savannah, Georgia. The Atlantic raged with ill temper. For days, a brutal gale had hammered the trade routes, whipping the sea into a wild tumult of slate-colored froth and icy rain. Yet for the München, this was just business as usual. She sent a routine position update via radio. All systems normal. 3 hours passed before a distant Greek cargo ship intercepted a distorted, broken SOS signal. The transmission wasn't coherent. It was a spectral echo of a voice, laced with terror amid the interference. Then nothing. One of the world's biggest and newest vessels had simply dissolved into thin air. A massive rescue effort ensued. Planes and vessels combed the icy, turbulent seas for days on end. Searchers anticipated spotting oil patches, scattered wreckage, or maybe rafts drifting on the waves. Instead, they turned up next to nothing. The München and her 28-man crew had plunged into the depths, though the sea eventually yielded one lone hint. Some months afterward, a solitary lifeboat drifted into view amid the currents. This vacant husk revealed the vessel's last moments. The boat hadn't been released properly. It had been ripped away from the superstructure. Positioned on the starboard flank, secured 20 meters, or 66 feet, above the waterline. In an ordinary tempest, even a vicious one, swells might surge across the deck, but couldn't climb that far. No ordinary seawater should have reached it. However, the examination of the securing pins showed horrifying brutality. They weren't corroded or unfastened. They had been snapped clean, bent backward by a tremendous pounding impact from ahead. This was the damning proof. It confirmed that a solid barrier of deep ocean water, not mere spray or bubbles, but a thick, pulverizing surge, had reared up at least 20 meters high and hammered the ship like a sledge. The dynamics of that collision point to a horrific outcome. The München probably didn't go down from a breach in her hull. She most likely met a towering whiteout wave, a lone, sheer breaker of staggering size that crashed into the bridge and upper works, shattering glass, inundating the command center, and wrecking the power grid, all in one devastating instant. She was likely adrift and powerless before the team could even process the threat. The München demonstrated that the sea could scale elevations engineers had ruled impossible. Still, this was inference. It was post-mortem forensics. The research world, wedded to normal distribution models, insisted maybe the ship had tilted or capsized into a standard breaker. A bent fastener wasn't enough. They demanded quantifiable data. They required the beast to imprint a trace. The München incident was a disaster, yet to the rigid statistical marine experts, it remained merely a tale of maritime loss. Metal bends, doors give way, skippers err. Lacking a concrete figure, absent a reading from an impartial instrument immune to fear or delusion, the creature lingered as folklore. Researchers craved that telltale mark, and on January 1st, 1995, amid the chilly, overcast void of the North Sea, the waters at last delivered it. The scene unfolded at the Draupner platform, a natural gas junction perched on slender steel supports, roughly 100 meters from Norway's shore. Unlike a vessel that bobs and yaws, muddling readings, an offshore rig stays anchored. It's fastened to the ocean floor. It serves as a steadfast gauge for gauging the sea's fury with unerring accuracy. As the New Year's storm lashed the installation, the average wave height, the reliable metric for assessing risks, climbed to 12 meters. This was turbulent, yet safely below the platform's tolerances. Per gale procedures, the workers had hunkered down inside. The setup ran on automatic. Suspended from the primary deck and aimed toward the turbulent dark depths below, a laser device protruded. This downward-facing wave sensor worked by emitting a light pulse toward the water's surface and timing its reflection to calculate the distance, doing so hundreds of times each second. It embodied stark, unyielding precision. At 3:20 p.m., with the winter dusk giving way to night, the laser captured a series of readings that forever upended conventional wave statistics. The graph displayed a wild, oscillating pattern of 12-meter swells, pulsing like the storm's fierce rhythm. Suddenly, the trace shot straight upward, from an expanse expected to yield no more than around 15 meters waves. A colossal wall of water surged forth. No preceding deep valley marked its approach. It defied all patterns. It burst into existence, striking the platform at 18.5 meters above the calm water line, with an overall height from trough base to crest summit of 25.6 meters. It measured 84 feet of unyielding mass. Per the straightforward equations that guided the platform's construction, such a swell in that precise location carried odds of once in 10,000 years. It defied probability entirely. Still, it appeared there, etched in stark black lines on the record. The structure creaked under the assault. The surge battered the deck's underbelly, a zone meant to remain elevated in the safety buffer beyond any predicted swell. Some superficial harm occurred, yet the real blow landed on established knowledge. This became known as the Draupner wave. It marked the initial instrumental detection of a rogue wave. It immediately validated centuries of mariners' accounts. The sea operated non-linearly. Power could concentrate. The beast existed. Researchers reeled in shock. If such a force could strike a stationary rig in the North Sea, a thoroughly charted and surveilled ocean region, what lurked in the remote, unobserved expanses of the Pacific or Southern Ocean? The insight sent shivers through the field. Our prior ignorance had left us vulnerable. We had dismissed these incidents as infrequent, once-in-a-lifetime aberrations. But as our focus shifted skyward, transitioning from the robust supports of drilling installations to the quiet void of orbit, we soon learned the seas brimmed with such threats. The satellite age was dawning. To comprehend the full danger's magnitude, people needed to rise above the waves. We had to withdraw from the tempest's roar and mist, observing the waters from the icy, soundless perch of outer space. During the early 2000s, the European Space Agency initiated an effort that would transform our perception of the marine world. Named MaxWave, it adapted a pair of planetary monitoring satellites, ERS-1 and ERS-2. These weren't optical imagers, they functioned as aerial radar arrays. Circling far overhead, they beamed microwave signals toward the seas. Timing the returning signals allowed them to chart the ocean's surface roughness with remarkable accuracy. They pierced clouds and night to gauge wave elevations. The team behind it anticipated validation of long-standing assumptions. They directed the satellites to examine 30,000 imagelets, brief ocean glimpses captured across 3 weeks. Based on traditional linear projections and the bell curve distribution, they forecasted at most 1 or possibly 2 enormous waves amid all that information. The findings left experts speechless. Over those mere 3 weeks, the orbits uncovered not a single one, but 10 enormous rogue waves. 10 behemoths, all surpassing 25 meters, prowling the world's waters. And this represented only those glimpsed in the satellite's limited sweeps during fleeting observations. Extending these observations across the globe yielded a horrifying projection. Right now, any day, countless rogue waves probably traverse the planet's seas. They aren't sporadic rarities. They aren't century-spanning occurrences. They form an ongoing, turbulent aspect of ocean life. They emerge, shatter, and dissolve constantly, minute by minute. Many swell and recede in the vast, empty voids of the Southern Ocean or Pacific. Seen solely by seabirds like the albatross, they plunge into shadowed depths, unleashing vast power on emptiness. Yet the seas teem with activity. Trade routes pulse as the world's commerce veins. Drilling sites anchor to continental edges. And suddenly, we recognize the ocean not as a serene expanse marred by occasional calamities, but as a field laced with hazards. The orbital views showed these waves struck without prejudice. They arose amid gales, certainly, but also in seemingly benign circumstances. Importantly, the data showed that these massive waves weren't limited to the remote depths where vessels could simply weather them. They could surge up perilously near familiar shores as well. The following key discovery didn't emerge from the vast Atlantic trenches or the untamed Southern Ocean. Instead, it arose in the near-shore waters of the Pacific Northwest, merely miles from bustling coastlines, demonstrating that the beast can stalk even the shallows. For years, experts assumed these colossal waves were exclusive to the profound open seas. We figured they required the endless expanse of the high seas and the immense pressures of the ocean floor to develop. We presumed that as they neared land, interaction with the bottom would diminish their force, disrupting their cadence and stripping away their strength. Yet in November 2020, along the shores of Vancouver Island in British Columbia, the waters demonstrated that safety is an illusion everywhere. The site was Amphitrite Bank, a scenic coastal zone celebrated for its dramatic allure, where the Pacific surges toward Canada's lush, temperate forests. This isn't the profound void, it's the continental margin. That day, conditions were choppy, though far from apocalyptic. The significant wave height, that misleading standard we rely on, hovered at about 6 meters. It was just a typical winter surge, navigable for ships and containable by seawalls. Drifting amid this undulating expanse was a Marine Lab sensor buoy. It rose and fell steadily, capturing readings and monitoring the coastal pulse. Up, down, 6 meters, 5 meters, 6 meters. Suddenly, the routine broke. From within that unassuming 6-meter expanse, one immense surge exploded upward. It towered to 17.6 meters. To an untrained eye, 17.6 meters or 58 feet might pale against the 100-foot behemoths of the deep Atlantic. But in rogue wave dynamics, scale is contextual. The dread stems from the proportion. The Draupner wave, which shattered illusions in the North Sea, stood about 2.5 times taller than nearby swells. A rare, probabilistic event. The Ucluelet wave exceeded its companions by almost 3 times. Proportionally, it's the most intense rogue wave humans have ever documented. Picture yourself aboard a modest fishing vessel in those waters. You're handling moderate, predictable rolls, settling into a steady pattern. Then, abruptly, a surge triples the scale of everything around it looms ahead. It's akin to scanning a line of 2-story homes only to witness a 6-story high-rise erupt straight from the ground. It crested with ferocious intensity that could demolish a trawler before plunging back into the 6-meter turbulence. The Ucluelet incident served as a stark alert. It unfolded only 7 kilometers offshore. This showed that such waves aren't mere remote perils drifting through trade routes. They prowl the shallows too. They can erupt on continental shelves mere steps from our seaside towns. Their presence is now verified. We've gauged them via lasers, monitored them from orbit, and recorded them with buoys. The legend is over. The threat is undeniable. Yet data in reports feels distant. To genuinely appreciate this force, we need to shift from charts to the sea itself. We should envision the raw mechanics of the occurrence. We must dissect the form of the menace. We're delving into the structure of fear. We've examined the metrics. We've followed the stark traces on laser plots and radar grids. But figures, however staggering, remain detached. To grasp the rogue wave fully, to sense its raw impact, we have to abandon the calculations and gaze at the waves. We need to position ourselves on the bridge and peer skyward. We must break down the monster's form. During an ordinary gale, the sea forms gradients. Even in a typhoon, a typical wave resembles a slope. It features a broad base, an extended sloping rear, and a peak. A vessel encounters it, climbs along it, gliding up the front like a vehicle ascending a sharp incline. There's lift. There's a predictable cycle of rise and drop. But a rogue wave disrupts this design. It's no slope. It's a sheer drop. Eyewitnesses, whether from massive cruise ships or lone sailors, invariably resort to identical vivid language. They skip talk of undulations. They speak of a foaming barrier. That's the rogue's hallmark. Born from abrupt energy, siphoned from adjacent waters, or the amplifying overlap of various wave groups. It turns abruptly vertical. It violates the usual balance of elevation to breadth. It shoots upright from the briny face. Envision yourself at the helm of a cargo freighter in the North Atlantic. Darkness prevails. The water's a turbulent mosaic of shadow and slate, lit solely by onboard floods. You're scanning ahead, observing the skyline heave and dip. Then, the skyline vanishes. Rather than gradually vanishing, the horizon gets obstructed. A massive wall of water surges up right in the ship's path, stretching across your entire view, from one side to the other. It's towering so much that you tilt your head back just to glimpse its peak. Unlike typical waves, which feature dark water topped by frothy white crests, this front is frequently all white. It's a breaker on an enormous scale. The leading edge slopes so sharply that gravity yanks the top downward, even as the wave is still taking shape. Water tumbles over the sheer drop like a cascading falls, forming a turbulent, foam-filled veil. In the darkness, this imparts a spectral, luminous quality to the behemoth. It's as if raw, explosive motion sparks a kind of bioluminescence, and it's far from quiet. Ordinary waves murmur or crash in a steady pattern. But a rogue wave, thanks to its abrupt incline and the bubbles trapped in its crumbling facade, produces a noise akin to a speeding cargo train or the deep growl of a sliding mass of snow. You sense it as a profound, throbbing pulse vibrating through the vessel's metal frame, long before the deluge arrives. That upright menace is precisely what renders it so deadly. No ship can crest a sheer barrier. The front end can't rise swiftly enough. When the hull collides with a rogue wave's surface, it's not encountering fluid as we typically imagine. Instead, it's smashing into something rigid. At velocity, water turns unyielding. Engineers have estimated the striking force of such a collapsing rogue at close to 100 tons per square meter, tenfold the force of a standard gale-driven swell. That's sufficient to warp metal panels, crack sturdy windows, and fracture a tanker's spine like brittle kindling. The onslaught packs the punch of a tumbling hillside. It scours the upper deck bare. It demolishes the control room. It overwhelms the air vents. And then, almost as abruptly as it surged, it crumbles. Being inherently precarious and overloaded with borrowed power, the rogue wave is a fleeting monster. It endures maybe half a minute or a full one at the outside. It wreaks havoc and then melts away into the ocean's disordered, jumbled swells. All that's left is debris and a dazed hush. Yet the barrier's loftiness and the crest's pulverizing mass represent merely the initial phase of the horror. The surge isn't merely a peak emerging from flatness. To form a summit, the ground has to drop away. For the liquid to ascend, it first has to descend. Prior to ramming the barrier, the ship must endure the plunge. Now we turn to the element that frequently dooms the craft even prior to the wave's impact. We peer into the void. Yet again, the barrier's elevation and the crest's smothering heft constitute just the opening act of dread. Ocean dynamics obey a basic principle of trade-offs. You can't erect a peak without carving a depression. The fluid forming that froth-crowned precipice must originate from somewhere. It draws from the immediate foreground. Before unleashing, the giant inhales deeply. It drains the sea. This generates a phenomenon that those who live through it describe with greater fear than the surge proper. They term it the void. Picture the ordeal. You're aboard amid the gale, the ship rising and dipping in a predictable tempo over the undulations. You've adapted to the motion. Suddenly, the pattern shatters. The vessel tops a routine swell, dips its prow to glide down the reverse slope, and continues plummeting. The sea under the bottom has evaporated. To amass its stature, the rogue wave has pulled in so much volume that it has gouged a profound, sheer-walled gully straight ahead in its trajectory. The ship tilts ahead, not at a mild 10 or 15 degrees, but at a nauseating, inconceivable 30 or 40 degrees. It resembles plummeting in a plummeting lift, more than navigating. This marks the instant of unchecked descent. The feeling blends total suspension with panic. Unsecured gear slams into the front partitions. Crew members tumble from their beds, and far below decks, the acoustics shift. As the rear end soars upward, the screw emerges from the water. It forfeits its hold on the medium. The drag disappears, causing the enormous motor to rev wildly, emitting a shrill, metallic howl that resonates through the structure's iron framework. Deeper you plunge, gliding into shadow. From this depression's nadir, the sight is nightmarish. The sea no longer surrounds you. You're confronting an endless chasm. To either flank, liquid rises like canyon walls. And forward, gazing upward from the depression's floor, the rogue wave's facade looms overhead. Not merely 20 meters tall, but seemingly twice that owing to the pit's depth beneath you. It's akin to being at a barrier's foot an instant before rupture. This void is the real destroyer. It sets the deadly snare, with the vessel aimed straight downward, accelerating swiftly into the trough's depths. It fails to raise its prow. Buoyancy vanishes entirely. The ship turns into a projectile, hurtling toward the sea floor. Upon hitting the trough's nadir, it crashes against the rising wave's underside. The front plunges deep. It embeds in unyielding liquid. The ship halts abruptly. Then the towering mass crashes down upon it. What was once the elevated, secure bridge now bears the brunt. Seawater engulfs the whole craft, ripping off rescue boats, aerials, and rigging. In fortunate cases, the ship trembles, shakes off the deluge, and climbs back up with a laborious creak. In dire ones, the immense pressure of the cascading water on the forward area fractures the structure clean through. Such is the structure of the void. The beast isn't merely a bludgeon, it's a concealed snare. Yet the sea holds one last vicious twist in this pattern. Rogue waves typically strike alone, an isolated freak amid turbulent waters. But on occasion, though seldom, the physics conspire to generate not a lone colossus, but a sequence. At times the creature arrives with companions. A lone rogue acts like a marksman. It's one precise strike emerging from obscurity. However, another form of this dread follows a harsher, more savage rationale. This isn't precision fire. It's an onslaught. Sailors have murmured of this event for ages. They bestowed upon it a title that seems deceptively mild, a metaphor drawn from myth and dread. They term it the Three Sisters. In the stark terms of hydrodynamics, it's known as a wave packet, a cluster of aligned behemoths moving in unison, bound by harmonic timing. But to the skipper at the helm, it's a fatal verdict. The peril isn't solely in the scale, it's in the timing. It's the utter elimination of any respite for recovery. Ships are built for endurance. They're buoyant like corks. When a colossal swell strikes, the hull pitches, it quakes, it ingests seawater. Yet with a moment's grace, natural forces take over. The excess drains via the outlets. The frame rights itself. The propulsion grips the waves anew. The vessel regains its poise. The Three Sisters rob it of that vital pause. The onslaught opens with the lead sister. She's a titan, a barrier of liquid that batters the ship with the intensity outlined earlier. She shatters panes, inundates the topside, and tilts the craft perilously to one flank. An acute 40-degree incline. Illumination sputters out. The team descends into disorder. During an ordinary gale, there'd be an interlude, a brief calm, an opportunity to gauge the harm and pivot into the gale. But prior to the ship steadying, before the vast volume of seawater can sluice from the bow area, the follow-up sister descends. She strikes a battered prey. Since the vessel already leans, already laden with ingress, it retains no lift to surmount the peak. It stays pinned. The second sister doesn't crest over the ship. She pierces it. She engulfs the frame. The ocean's mass atop the deck turns oppressive. This triggers the free surface effect. Vast quantities of confined water surging wildly within the shell, upsetting the balance point, rendering any upright stance impossible. The ship now flounders. It's motionless amid the swells, submerged low, burdened and vulnerable. And then, with a grim, pulsing certainty, the final sister lands the fatal blow. No defenses remain. The frame, strained past its break-in threshold by the torsional strains of the prior strikes, just yields. It cracks, or the ship, barred from righting, simply overturns fully into the depths. The horror in this progression lies in its cadence. It's a methodical 1-2-3 assault from the sea. Executed with a pugilist's accuracy, it unfolds swiftly. Within under 2 minutes, even a massive tanker can shatter into fragments. Those who endure such clashes, and they're scarce, speak of an overwhelming sense of mental defeat. It's the dawning that the sea isn't merely disordered. It's unyielding. It offers no halt for recovery. These form the dynamics of the assault. We've examined the barrier, the depression, and the cadence. We've broken down the fiend using the detached instruments of research and scrutiny. Yet metal and equations don't capture everything. To grasp the rogue wave fully, we need to descend from the command post into the quarters below. We must abandon the equations and delve into recollection. We must heed the accounts from those who faced the watery rampart and survived. Steele Foster's denial, boarding a contemporary cruise liner or ocean-crossing behemoth, we enter a seafaring metropolis. We're enveloped in terrestrial luxuries. The gentle whir of climate control, the chime of fine glassware in the mess, the well-illuminated passages adorned with paintings. We're buffered from the truth. Outside, the sea merely serves as a picturesque vista, a vast expanse of blue framed by sturdy, triple-layered reinforced windows. We lose sight of the fact that we're venturing into untamed territory. Yet for those who endure a rogue wave's assault, that sense of security crumbles in one brutal instant. The recollection of such an ordeal seldom focuses on the mechanics involved. Instead, it's the bizarre invasion of nature's raw force into everyday civilized life that lingers. Consider what happened to the MS Bremen. Back in 2001, this opulent cruise liner was crossing the South Atlantic. Built for indulgence, it ferried sightseers eager for Antarctica's excitement while enjoying hotel-like protection. Conditions were choppy, yet the vessel managed well. Aboard, guests lounged with books, napped or dined leisurely. Then everything shifted. From the bridge, Captain Hines spotted an immense wall of water filling his entire view. It wasn't cresting gently, it was crashing down. A 35-meter behemoth, a towering 100-foot rampart of churning foam and rage, bore straight toward the vessel. The strike wasn't a mere drenching, it was a brutal smash. Shards exploded through the fortified bridge windows like brittle candy. Suddenly, the ship's command hub. Its computers, charts, and controls vanished beneath surging water. Power grids failed in sparks. Propulsion halted. Down in the lower decks, riders faced abrupt, bewildering panic. The once steady craft heeled sharply. Items skidded wildly. Dishes shattered, and darkness fell. Picture the mental anguish in that chaos. Tucked in a plush stateroom, pitch black, adrift in Earth's most ferocious waters. The liner lay powerless, yawing sideways into the swells, tumbling through the valleys. The sea's furious roar battered the exterior, clawing at the shell, insistent on breaking in. For 40 minutes, the Bremen bobbed like a helpless buoy amid the Titans. Only the crew's frantic ingenuity, rigging the motors by hand, swung the prow into the gale just in time to evade the next colossal threat that might have flipped them over. Or think about the Louis Majesty. In 2010, she cruised the Mediterranean, a body of water we typically view as placid. Still, its depths harbor fierce moods. Folks relaxed on the fifth-deck lounge, sipping tea amid casual chats in the cozy confines. Abruptly, gloom darkened the space. Beside the hull, a massive surge climbed past the upper levels. Panes burst inward. The flood didn't merely dampen the floor, it erupted inside. A relentless cascade of emerald depths hurled bulky furnishings about like flotsam. The result was a maelstrom of brine, splintered panels, and twisted metal. What had been a haven turned lethal in moments. The force claimed 2 lives outright from flying debris and the deluge. Those who lived recall the noises vividly. Not the wave's thunder, but the vessel's own agony, the hull's deep creak as it strained beyond limits, the wail of rupturing joints, followed by an oppressive quiet as if the structure paused, uncertain of survival. Such accounts deliver a harsh lesson. Our creations aim to dominate nature, warding off peril and chill. But rogue waves expose how tenuous our dominance truly is. In mere heartbeats, the sea peels back our polished facade, confronting us as vulnerable, fleeting creatures atop an vast, uncaring force. These brushes with disaster alter our perspective on the waters. They compel questions. If taming the beasts eludes us, might we at least detect them early? Fortify our defenses more robustly? Now we shift from history toward tomorrow. We explore how people wield their sharpest asset, the intellect, to counter the turmoil. This heralds an era of foresight and innovation. The Munchen's demise and the Bremen's close call weren't mere mishaps. They jolted the field of ship design. For generations, maritime engineering rested on hopeful assumptions. Vessels followed linear wave models, crafted for a reliable sea where swells were smooth rises a keel could navigate. We gauged hull strains from the 100-year wave, a probabilistic notion pulled from normal distributions. Essentially, we erected fortresses against an imaginary realm. When a freak swell assaults, conventional principles of flotation and pressure fall apart. The clash isn't fluid dynamics, it's impact force. The craft doesn't glide atop the surface, it slams into it. Specialists term this underscore, quote, _4_. During typical gales, a prow cuts the flow, scattering foam and spray aside. However, when a vessel plummets into the trough, created by a rogue wave, and crashes against the base of the approaching crest, the front end stays submerged and unable to rise. The swell surges right over the deck. This counts as green water, dense, bubble-free seawater. It tips the scales at a metric ton for every cubic meter. As countless tons of this solid mass hammer down on the forecastle, the impact isn't merely shoving, it's a devastating strike. Such force can buckle steel hatch lids, folding them inward just like thin aluminum. It might also rip away the deck's pipes, cranes, and wave deflectors. Consequently, we've been forced to overhaul our design plans. No more building for typical conditions, we're now accounting for the outliers. Today's vessels are transforming into fortified strongholds. Take a glance at the bow on a cutting-edge ultra-large container ship or a dedicated offshore service vessel, and the shift is evident. The prows are rising taller and more flared out, engineered to deflect green water, clear of the deck, prior to it turning into an overwhelming burden. Those breakwaters, the sloped metal barriers up front, are getting tougher, upgraded into protective barriers, safeguarding the cargo in their wake. The bridge, serving as the vessel's command center, is being repositioned. On the Muncheon, its low placement proved deadly. These days, ship designers are elevating the superstructure and shifting it rearward, prioritizing elevation for security and aiming to keep the crew beyond the grasp of that towering foam. The viewports aren't simple panes anymore. They're composed of layered composites, rigorously tested against forces that could implode a submersible. Yet, the boldest modifications are unfolding in the riskiest environments. The oil rigs, the drainer wave, reshaped the offshore sector permanently. Prior to 1995, specialists computed the air gap, the space from the turbulent ocean surface to the platform's steel underbelly. Using straightforward linear approaches, they believed the clearance was sufficient. Measurements from New Year's Day revealed otherwise. The sea could climb beyond what their equations predicted. Today, the platforms are being elevated on extended legs. We're bolstering the spider deck, the platform's lower framework, hardening it against the violent upward thrust from a wave peak. We're constructing installations that anticipate the sea's intent to destroy them. The conflict has shifted from the shipbuilding docks to the digital realm. We don't rely on estimates anymore. Instead, we model scenarios in the buzzing data centers of ocean engineering labs and design companies. We generate simulated tempests. Through computational fluid dynamics, we craft virtual hulls and plunge them into simulated irregular oceans. We observe the metal flexing. We track the hull's oscillations, known as whipping, where a freak wave's hit sets the whole structure resonating like a gong, eventually fracturing the keel from repeated stress. We're crafting more resilient, intelligent, and elevated designs. Still, metal has its breaking point. Regardless of hull thickness or bridge height, the laws of physics always side with the sea. If the swell grows massive enough, or its power concentrates intensely, the ship will shatter. Fortification offers only reactive protection, a wager that we can endure the hit. But the best way to endure is to evade the blow entirely. Achieving that requires more than reinforced plating. It demands advance notice. We must detect the threat approaching before it lands. We're transitioning from brute force construction to foresight-driven strategies. We're endowing ships with foresight. Fortification is merely reactive shielding, a bet on absorbing the impact. Yet true endurance means sidestepping it. That calls for more than metal alone. It requires warning time. We need to spot the beast emerging from the turmoil before it attacks. We're stepping into an era of forecasting, where combating rogue waves transfers from the tangible domain of welders and fasteners to the rapid, unseen sphere of code and sensors. Forecasting a rogue wave poses a challenge because it's inherently an unpredictable outlier. It defies the norm. Conventional meteorology can alert a skipper to an incoming gale next Tuesday or estimate peak wave sizes, but it can't pinpoint the precisely at 3:42 a.m. along certain coordinates. Converging wave sets will form a watery barrier, or at least it couldn't before. Researchers at MIT and top research centers are developing advanced AI to monitor the waters. They're inputting years of wave records, the erratic readings from buoys and optical sensors, into machine learning systems. They're instructing these AIs to identify disorder signatures. The programs scan for early indicators. The faint, nearly undetectable shifts in the wave patterns mere moments before a giant forms. They detect how power accumulates, how wave clusters start aligning, and they're uncovering a detectable pattern. Early outcomes are encouraging, yet alarmingly short-lived. The AI can forecast a rogue wave, though it offers only seconds of heads-up. The system offers no more than a couple of minutes' notice, maybe 2 or 3 at best. Just 2 minutes. For a huge container vessel cruising at 20 knots, that's barely a moment. It's too short to reverse course. It's insufficient to escape the oncoming surge, yet it could still mean the difference between life and death. Picture yourself on the bridge of a futuristic vessel amid a raging tempest. A piercing alarm pierces the chaos. A crimson alert blinks on the control panel. The artificial intelligence has spotted the buildup of power in the shadows. Rogue wave incoming. Collision in 120 seconds. Those 2 minutes allow for activating the all-hands alert. They're sufficient to evacuate the open areas, ushering the team from precarious outer paths into the vessel's fortified core. They're enough to seal the bulkhead compartments. They're enough to adjust the prow by 5 degrees against the incoming surge, positioning the ship to absorb the impact at its most resilient angle, rather than a weak side. To enhance this electronic sentinel, we're installing LiDAR, light detection and ranging, on vessel prows. These laser systems probe the sea ahead, charting the water's contours instantly. They're hunting for depressions. They're seeking out the sharpness of rises. Our goal is to equip ships with instinctive responses. Yet despite advanced algorithms and beams piercing the gloom, we're always one step behind, as the sea proves an ever-shifting adversary. The arena keeps evolving. We're crafting protections suited to the current marine environment. But tomorrow's seas could transform into a much wilder, more ferocious force. We're injecting warmth into the air. We're heating the waters, and warmth equates to power. Through climate alteration, we might be nourishing these behemoths. Now we face the query that troubles every marine scientist amid rising temperatures. Are these colossal waves growing in scale? We have to grapple with the basic physics of a hotter planet. Heat equals energy. Nothing more complicated. Over recent decades, the planet's seas have taken in over 90% of the surplus heat from our greenhouse emissions. The depths are heating up. To ecologists, that spells dying reefs and migrating fish stocks. But to experts in mechanics, it signals heightened activity. The sea is becoming electrified. It's like a capacitor pushed beyond capacity. This added warmth doesn't linger idly. It fuels gusts. It intensifies tempests. And in the end, it elevates the liquid masses. Data from the past 3 decades reveals a worrisome pattern. The waters are turning more turbulent. Satellite altimetry readings, which track ocean elevations from orbit, show rising global wind velocities and correspondingly taller typical waves. The shift stands out starkly in the planet's climatic powerhouse, the Southern Ocean. There, the infamous roaring 40s and furious 50s whip around Antarctica without barrier. With atmospheric warming, these gales grow fiercer. They squeeze closer to the ice cap, accelerating their whirl. This infuses greater force into the depths, generating broader, mightier baseline undulations that spread across the Pacific, Atlantic, and Indian basins. Still, the real threat isn't merely waves gaining a few extra centimeters on average. The peril hides in the equations governing these anomalies. Recall what defines a rogue: an extreme deviation, an amplifier of the prevailing conditions. When the key wave height, the norm, increases, the outlier doesn't scale evenly, it amplifies. A 10% surge in storm vigor could trigger a far steeper climb in those abrupt, chaotic barriers of fluid that erupt from the turmoil. In essence, we're elevating the limits. We're forging an era where the once-in-a-century monster, the supreme hazard standard for naval architects, could strike every decade. We're shortening the interval to disaster. Vessels constructed now, engineered to endure the fiercest gales of the last century, might prove tragically inadequate against mid-21st century assaults. And these threats are pushing boundaries. As seas heat, the fuel for typhoons and cyclones extends beyond equatorial zones. We're witnessing intense systems holding form at higher and lower latitudes, dragging turbulent, unpredictable swells, the ideal cradle for rogues, into regions long deemed serene. The coming ocean will surge higher, move quicker, and pulse with amplified force. It's a realm of loftier foam barriers, profounder troughs, and more punishing triple assaults. This is the broad perspective, narrated by orbital sensors and massive processors, a tale of global heat, flows, and liquid motions. Yet regardless of the volumes of information we collect or the rays we direct seaward, the deep stays untamed. For the solitary sailor adrift in infinity, projections and simulations fade to nothing. When you're afloat, the sea defies charts and lines. It becomes a living force. It becomes a consciousness. So, let's step away from the safety of the command center and head back to the open deck. Now's the moment to delve into the mental experience of confronting the void in solitude. We're stepping into the psyche of the lone mariner. Out in the deep sea, solitude is total. Music. The closest people might not even be on the planet. They could be aboard the International Space Station circling above. In such surroundings, the human mind, wired through evolution to spot patterns, to pick out faces amid foliage or threats in the underbrush, starts to falter. It begins imposing purpose on the waves. This is pareidolia writ large across the globe. A skipper by themselves in the cabin at 3 a.m., fighting through a storm in the Southern Ocean, ceases to view the swells as mere mechanics. The gale, screaming past the sails, no longer registers as shifting atmosphere. It starts resembling a whisper. The surges quit appearing as haphazard mounds of liquid. They start seeming purposeful. They appear to observe. Those who survive rogue wave strikes frequently recount an eerie premonition right before the crash. They talk of sensing pursuit. Sailors routinely mention a hostility lurking in the depths. They portray the rogue wave not as chance music, but as some entity that reared up to peer at them. They recount how it appeared to pause, waiting for peak exposure, like when the vessel was broadside or the captain was down below, brewing tea, before slamming down. Naturally, this is all illusion born of the psyche. The sea isn't sentient. It harbors no grudge against the vessel. It has no awareness of the vessel's existence. Yet the mental burden of the rogue wave can wound nearly as deeply as its brute force. Music. It erodes the mariner's faith in reality. We depend on the idea that the natural world is neutral. But a rogue wave strikes as intimate. It strikes as aimed. Music. It ruptures the storm's cadence, shattering the unspoken pact between seafarer and waters. As that mass of liquid surges from the shadows, ignoring the pattern of the prior thousand swells, it registers as disloyalty. And for land dwellers gazing seaward from the coast, a faint instinctive disquiet persists. We stare into the inky depths and sense an ancient alarm echoing within. Music, we recognize our place isn't out there. We're land-bound beings, shaped by solidity and weight. Outsiders in a realm of flux. The rogue wave embodies that rejection at its peak. It's the sea asserting with brutal precision that our inventions, our hulls, and our bravery are mere visitors, and visitors can be shown the door. This leads to a tough philosophical insight. We'd prefer to think the universe revolves around us. We'd prefer to think that, with enough intellect, caution, and grit, we can tame the perils of untamed nature. But the sea imparts another truth. It imparts the truth of the uncaring void. Music. As a species, we hunger for purpose. We're weavers of tales. We behold a tempest and perceive wrath. We behold a serene expanse and perceive serenity. We cast our feelings, our ethics, onto nature's backdrop. When a rogue wave engulfs a craft, vanishing it into the gloom, our gut reaction is to question the cause. We hunt for explanation, a lapse in the leader's decisions or spite in the currents. But the sea delivers a sterner, icier wisdom. It delivers the wisdom of apathy. The author, H.P. Lovecraft, contemplating the shadowy Atlantic, grasped this more acutely than most. He saw that the real dread of the universe isn't monsters bent on our destruction. The real dread is the universe's ignorance of our presence. A rogue wave incarnates this universal apathy. It isn't vicious. Music, it isn't malevolent, it's just a formula evening out. Recall the principles we've covered. Gusts impart momentum to the surface. Flows bunch up the undulations. Chaotic equations siphon strength from certain crests to amplify others. When that column of fluid climbs 30 meters skyward, it's not assaulting. It's simply following thermodynamic rules. It's mass music and motion correcting a fleeting disequilibrium. Should a boat occupy that precise spot, at that exact instant, the surge flattens it. Should the waters lie deserted, the surge ascends, collapses, and dissipates into the night with identical ferocity, observed music solely by the heavens. The outcome remains unchanged. The motive is absent. This awareness terrifies, yet it also enlightens. It underscores that our world isn't a sanctuary tailored to our ease. It's an immense, ever-shifting, at times savage apparatus. The waters enveloped this sphere eons before we emerged from the slime, and they'll envelop it eons beyond our extinction. The white wall offers a peek into an era predating humanity, a domain of unbridled force, functioning on vastness where mortal drive shrinks to irrelevance. The surge serves as a stark cue to our vulnerability. When confronted by a cascade of 1,000 tons of water crashing down, our gadgets, our status, and our fortunes lose all relevance in an instant. The sea pairs us back to our primal essence. It shrinks us into mere fragile, heat-generating beings struggling to stay afloat in the chill. Yet we refuse to back away. We won't linger safely on land. Even with the ocean's utter apathy and the lurking beasts we now recognize in the depths, we keep sending out our vessels. This leads us to the ultimate truth about our bond with the sea. We can't tame the freak wave. We can't halt the unyielding laws of physics. Instead, we have to adapt in another way. We have to adapt to existing under the looming presence of that colossal force. Our society thrives on calculated gambles. Consider the space around you at this moment. The devices you're relying on, the garments covering your body, the energy fueling the bulbs above, nearly everything has crossed the waves at some stage. 90% of all goods produced, purchased, and traded by humanity journeys by sea. The worldwide marketplace forms a fragile, unseen network of metal boxes, traversing the unpredictable boundary between gusts and swells. Each day, countless ships, from massive supertankers stretching a quarter-mile loaded with raw petroleum to modest trawlers harvesting fish off the Grand Banks, head into the unpredictable expanse. The skippers and sailors aboard these craft grasp the reality. They're aware of the orbiting satellites monitoring from space. They understand the ship's exteriors are fortified with strong tensile steel. They rely on advanced programs that crunch data to guide them clear of stormy lows. Still, they carry an unspoken conviction that peril can never fully vanish. They carry the awareness that rare disasters lurk. Being a sailor in the 21st century means forging a covenant with the waters. It's a compact, promising to deploy our smarts, our innovations, and our alertness to lessen the threats. But we recognize the threats as inescapable. We concede that charts have gaps. We concede that the typical wave height, that reassuring norm, can deceive us at crucial times. This mindset fosters a distinct way of life. It's what forges such a profound connection among those who sail, cutting across tongues and borders. They hold a private insight into the planet's vastness. They've witnessed the sea in fury when the skyline vanishes beneath a barrier of foaming surf, and they realize security isn't assured, it's earned. And there's an odd allure in this vulnerability. The freak wave, despite its dread, also honors the wild essence of our world. In an era where we've concreted over woodlands, blocked waterways with barriers, and illuminated the darkness so intensely that constellations fade from view, the sea stands as the final, authentic frontier. It's Earth's sole domain where we hold no dominion. The beasts ground us in humility. They signal that we're inhabitants of a dynamic world, a world with its own heartbeat. And that heartbeat, the cadence of breezes and breakers, isn't merely a hazard. It's the force propelling everything. Throughout this exploration, we've viewed the wave as an assailant. But now we need to alter our lens once more. We should regard the wave not as a destroyer, but as a builder. Across this extended voyage, we've examined the wave as an assailant. We've dissected its crushing force, its towering scale, and its potential for ruin. We've lingered on the wrecked deck of the Munchin, sensing the dread of the Wara. Yet ending the tale, there would leave it unfinished. It would miss the core of our world's character. We need to adjust our view one last time. We should draw back from the panicked vessel, retreat from the churning seas, and regard the entire ocean as one unified whole. A wave isn't simply liquid, it's power rendered tangible. To grasp the freak wave, we shouldn't focus on the waters alone, but on the distant sun, blazing 150 million kilometers away. Solar warmth bathes the tropics, heating the atmosphere. That rising warmth forms a void, drawing in frigid air from the poles. This global circulation spawns the trade winds and the prevailing westerlies. These unseen currents of breeze extend to touch the ocean's skin. By the basic drag of wind over fluid, the sun's fiery heat converts into the surging action of the waves. Thus, a wave is essentially captured solar power. It's a reservoir of stellar energy gliding over the abyss. When we behold that 30-meter surge emerging in the Southern Ocean, it's not spite we perceive. It's a buildup of might. A freak wave serves as a directed ray of our nurturing star, channeled via air and water. It's the Earth shuttling heat from tropics to poles, a vital process sustaining life. This power transfer operates with remarkable precision. A storm brewing near Antarctica's edge can unleash a swell that journeys for 2 weeks, spanning 10,000 miles across the boundless Pacific before softly crashing against Alaska's coastline. Over that immense stretch of shadowy expanse, it retains nearly all its strength untouched. The sea possesses an impeccable recall for such force, and this ferocity serves an essential purpose. Envision a planet devoid of waves, a realm where breezes never muster the strength to stir the waters into motion. The sea would stagnate into a hushed, motionless lagoon. Absent the turbulent, forceful blending propelled by those waves, atmospheric oxygen couldn't penetrate the profound depths. Deep-sea riches, like the nitrates and phosphates that accumulate on the seafloor, would remain trapped below, never rising to nourish the surface. Plankton would perish, fish would gasp for air, majestic whales would go hungry. The ocean would transform into a layered, barren tomb, choked by its own inertia. The terrors we dread, the tempests, the fierce blasts, and rogue waves themselves act as the vital breath of the abyss. They function as the mighty stirrers. When a rogue wave shatters, hurling countless tons of foaming, aerated water down into the void, it infuses vitality into the shadows. It fuels the global flow that balances our weather patterns. The streams forming the Agulhas Trap are identical to those warming Europe's winters. The gusts that forge the Draupner wave mirror those delivering rain for the crops. Disorder isn't a flaw in the system, it is the very blueprint. Thus, viewing the rogue wave, we ought to perceive more than a destroyer. We should recognize the untamed, awe-inspiring, and daunting might of our dwelling place. This force courses via the seas, the skies, and in the end, through our very beings. As water-dependent beings on the brink of a water-dominated sphere, we perpetually sway with the deep's vigor. We stand tiny against the sea's enormity. Waves serve as a stark reminder that Earth isn't a lifeless stone, but a vibrant, pulsating machine. And this evening, as we unwind, that machine hums on. The pulse throbs, the gale subsides, the power ebbs away. We're set to head back to land. Our voyage has taken us afar tonight. We've abandoned the harbor's refuge, venturing into the 19th century mists. We've manned the deck of the Waratah, as the skyline vanished behind a surging barrier. We've gauged the unfathomable form of the Ramapo wave and examined the mangled metal of the Munchen. We've delved into the mechanics of the power pilferer and observed satellites probing the gloom, uncovering a realm alive with behemoths. We've witnessed the barrier, the void, and the trio of sisters. The Odyssey concludes. The squall ebbs. The moment to retreat has arrived. It's time to depart the wild, swaying planks of fancy and plant our feet on the steadfast, immobile ground. Yet prior to drifting off, let's cling to one last vision. Let's conjure the sea in this precise instant. In the inky depths of the Southern Ocean, isolated by thousands of miles from shore, the gales howl, the waters surge. And amid that obscurity, a colossus emerges. A swell siphons strength from its kin, surging ever upward, challenging the pull of Earth. It morphs into a sheer rampart of froth and night, a wordless temple of liquid poised in the void. It looms for an instant, invisible to mortal sight, then it plummets into the desolation with the impact of a tumbling skyscraper. It strikes, it ravages, then it dissolves. The sea recalibrates, equilibrium restores. Such brutality defines the world's truth. But you remain absent from that scene. You're right here. Sense the tranquility enveloping your space. No 60-knot blasts disturb it. Serenity prevails. Sense the firmness underfoot. No sway or tilt afflicts it. It's rooted profoundly in the planet's core. You're shielded within a bastion of solid terrain, fortified by epochs of tectonic history. The beasts exist, yet they're remote, confined to their perpetual far-off waltz with the tempests. They can't touch you. They're just tales, spectral surges, traversing a realm beyond your domain. Allow the specter of the foaming barrier to dissolve. Permit the storm's grip to ease from your frame. The rush that gripped the Ramapo's crew through sleepless nights doesn't claim you. Your vigil ends. Heed the quiet. It counters the thunder, a dense, soothing, enveloping shroud. Now supplant the rogue wave's specter with its counterpoint. Picture a coastline, a serene sandy stretch at dusk. The breezes have hushed. The sea has exhausted its rage. All that's left is a soft, undulating progression. Tiny ripples, mere inches tall, caressing the shore, whispering faintly, withdrawing, advancing anew. This is Earth's soothing melody. The deliberate, reliable thrum that has cradled existence through endless ages. Align your breaths to this cadence. Measured even, foreseeable, rising and falling, drawing in and releasing. The sea inhales and exhales. The world spins silently through the shadowed void. The colossal beasts slumber in the abyss below. And here you find security. Drift off to sleep. Sweet dreams. Though we mark a mere fleeting moment in time, there's an odd, yet soothing humility in our place. We've merged with the stone itself. Our story is etched deep into the planet's very crust. Eons beyond the stripping of the air, past the simmering of seas after the sun's vast swelling, that slender thread of irradiated polymers will endure. It's an imprint the globe can never erase, yet our inheritance extends beyond the strata. It lingers overhead as well, as the world fades, as breezes cease and particles come to rest. A quiet, shimmering band of relics keeps circling the lifeless husk. We don't rule this sphere. We're simply a stratum of deposition, a stratigraphic layer locked in stone. Still, this brings a curious contradictory solace. True, our traces on the land are fated to vanish under the relentless churn of the globe. But our mark isn't solely earthbound. We've achieved what no other life form in Earth's 4.12 billion-year chronicle has. We've reached the heavens, crafting a tribute that survives our home's demise. As the planet perishes, as winds halt and grit settles, that hushed, sparkling loop of remnants persists in revolving around the desiccated core. From the mid-20th century onward, we've encircled our globe with devices. We've propelled countless satellites, explorers, and booster remnants into the void. We've spun a lattice of titanium, gilded sheeting, and silicon encircling our abode. Many of these, the low-orbit observers, reconnaissance crafts, orbital habitats, networks of data links, are fated for downfall. They wander in the sparse high atmosphere where faint traces of vapor still exert pull. Drag acts as a subtle pilferer. Across scores or hundreds of years, it saps their velocity. Gravity prevails. They spiral inward to incinerate as meteors, their elements reclaiming the air they once departed. But in the outer reaches, another domain awaits. At 36,000 kilometers over the equator sits the geostationary zone. This precise, enchanting height aligns orbital pace with the planet's spin. A craft stationed there appears fixed in the firmament. No atmosphere stirs here, no storms rage, no corrosion creeps, no decay gnaws. The elements that topple earthly landmarks, gales, downpours, plant roots, crustal shifts, hold no sway. It's a domain of utter icy stasis. Picture the barren Earth, a billion years hence. The sun has bloated into a furious crimson behemoth. Seas have evaporated. The crust is a barren expanse of ashen powder and fused basalt. The Giza pyramids have crumbled to grains. The Great Wall has vanished. Our urban bases have plunged into the depths. But gaze skyward. Against the inky canvas of cosmos, tinged by the waning star's crimson glow, a band gleams. It echoes Saturn's rings, though dimmer, sparser, forged from alloys. These are our era's communication beacons, the broadcast links, climate watchers, majestic engines of our data epoch. They're inert now. Power sources expired ages past, processors locked in frost, arrays scarred by eons of tiny particle strikes. Yet they persist. They stand as mute guardians. They circle in an eternal, soundless waltz. They've evolved into faux satellites, a synthetic debris halo from our pinnacle craft. With no friction to pull them earthward, they'll circle for millions, maybe billions of years. They'll observe the biosphere's end. They'll mark the sea's evaporation. They'll note the tectonic drive's last falter. They're the orbital necropolis, yet also an archive. Should some extraterrestrial voyager traverse this system in the far-off era, long since we've faded or fled, they'd first behold the ravaged orb. They might probe the parched terrain and discern only stone. They might deem this sphere eternally desolate, untouched by vitality. But then their instruments would catch the band. They'd trace its form, the orbital elegance of its paths. They'd uncover the aureate engravings, inscribed circuits, intricate receivers aimed at a void now mute. And they'd comprehend, without landing or unearthing relics, they'd grasp that this stone once teemed. They'd sense a kind rose here that gazed upward. They'd infer we wielded tools, mastered numbers, and yearned to call through the emptiness. These orbiters are our dispatch adrift, not tossed to waves, but to time's endless current. These satellites stand as the ultimate evidence of our presence. The chart has shifted, the sea has perished, the mechanism has halted. Echoes linger in the stone and the heavens. We've ventured from the mirage of now to the scorching expanse of Panga Ultima, and at last to the hush of an endless grave. Our voyage has ended. The sequence is sealed. It's time to turn back. We need to retreat from the brink of the chasm, away from the barren tomorrow, and navigate home to the security, the coziness, and the pulse of the current evening. Tonight we've journeyed so very far. We've wandered from the snug, unchanging facade of today's layout into the blazing, parched core of Panga Ultima. We've observed the Atlantic seal shut, grinding our past into the foundations of mountains. We've witnessed the Pacific sink into the depths. We've traversed the searing dunes of the vast wasteland, endured the pounding deluges of intensified monsoons, and sought refuge in the shadowy, chilled hush of cavernous limestone. We've gazed into the core of the mantle's machinery and beheld the planet's geological demise. a hushed end a billion years ahead. And we've glanced skyward to spot our own mute metallic relics orbiting a lifeless sphere, the enduring witness to a race that once harbored dreams. Our voyage has concluded. The loop is complete. On the surface, this tale appears dominated by brutality. It's an account of impacts, outbursts, die-offs, and stillness. It's simple to sense insignificance amid such overwhelming powers. It's straightforward to perceive ourselves as perched on a belligerent creature eager to dislodge us. Yet if we withdraw a bit, if we examine this immense chronology, not through dread, but through clarity, the ferocity diminishes. The disorder settles into a pattern. In essence, the saga of supercontinents isn't one of ruin. It's one of regeneration. Our world isn't a lifeless hunk crumbling away. It's a dynamic entity perpetually reconstructing. The Wilson cycle, that gradual 500 million year migration from one Pangea to the next, forms the pulse of our planet. It represents the world's breath. Earth draws in, drawing land masses close, remaking aged, chilled seabeds in the mantle's blaze to melt and revive. Then it breathes out, splitting the terrain, spawning fresh seas, forging novel shores, and freeing vital minerals that spark life along the edges. We dread the motion due to our frailty. We fear alteration because our spans count in years, whereas Earth tallies in ages. But that motion preserves the world's vitality. Absent the sliding plates, the carbon loop would cease. Weather would lock into eternal ice or steam into a ceaseless Venus-like inferno. Our planet would have perished eons past, turning into a lifeless vault. The very shift that endangers us, the unstable terrain, is what nourishes us. It's the drive that balances the atmosphere we inhale and the liquid we consume. We're offspring of this wander. Our forebears arose in the fractured veils born from parting slabs. Our societies emerged on lush estuaries carved by weathered peaks. We exist, pondering and sensing, solely because the machinery deep within still churns. Thus, we ought to reconcile with the beast. Tomorrow's Pangea approaches, the blaze approaches, the quiet approaches. Yet none arrive this day. We're in an era of splendor. We've received a respite, a lovely, mild, steady interval amid the grand clashes. The Atlantic stretches wide, tempering the breezes. Showers descend. Land masses are dispersed sufficiently for seas to expand. We dwell in geology's perfect balance. The snare hasn't sprung. So as you rest this evening in your bed's gentle heat and shelter, guide your thoughts from the remote tomorrow. Allow the vision of the searing supercontinent to melt into shadow. Let the colossal salt expanses and poisoned waters fade into today's serene azure truth. Sense the pull, anchoring you to the sheets. That pull isn't mere physics, it's a clasp. It's the grasp of a world immense, weighty, and remarkably enduring. Here the room's quiet. It's no void, it's a subtle vibration. Picture the earth under your dwelling. Descend beyond the dirt, beyond the solid layer, beyond the shell. Far down, mighty streams of rock continue their flow. The mechanism turns deliberate and firm, bearing you, your town, your whole landmass on an odyssey without end. No need to fret over the end point. The pace is too languid to notice. Earth cradles you, the wheel spins, the colossus stirs, yet with the soft, unseen cadence of a parent swaying a bassinet. You're woven into the stone. You're bound to the waves. You're entwined in the flow. Release the chart. Release the hours. The globe spins softly through the hushed shadows, cradling your safety. Drift into rest now. Sleep well.